Unit 6.2, some ways to prove that two triangles are congruent. We say some ways because we're going to learn another way later, a couple more ways, but anyway. First three ways that we're going to learn to prove that two triangles are congruent are by side, 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 as we call it, SSS, side, 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 SAS, side, angle, side, ASA, angle, side, angle. Now, the first one, side, 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 says if all three sides of one triangle are equal to all three sides of another triangle, then the triangles are congruent by side, side, side. Now let's look at these examples because we got to do a little brain training, as I call it in Algebra 1. We've got one pair of equal sides, two pairs of equal sides, three pairs of equal sides. All three sides of the one triangle are equal to all three sides of the other, so the triangles are congruent by side, side, side. But notice we are supposed to name the similarity angle A, and I didn't do that in a good color. Angle A, if you notice, is across from the 5. So I'm going to put a red. Across from the 5 in the second triangle is the D, so angle D has to go first because it's opposite the 5, and the A was opposite the 5, so A must be equal to D. Angle B was opposite the 6. I circled it in green. Opposite the 6 in the second triangle was E, so B must be equal to E, so E goes in the middle. Angle C is opposite the 4, which I circled in blue, so we'll underline C in blue. Opposite the 4 in the second one was F, and so F must be named last. We must take our time to name the corresponding parts in order when we name that congruency. Now, in the next picture, you may go, well, there's not three sides marked. There's just this side, and I've got to calibrate my brain with how much off the marker is, so give me just a second to kind of get that figured out. Okay, and so we have this side AD is equal to that side AC, and then we have this side AB is equal to this side BC. So we have two sides of one equal two sides of another, but what about the third side? Well, the third side is exactly the same in both, and so we could say that BD of the left triangle is equal to BD of the right triangle, and we can say BD is equal to itself by reflexive property. This is where that reflexive property is going to come in. So let's think about the A. The A was opposite the black side there. C is opposite the black side. Since A is opposite the black side BD, and C is opposite the black side BD, then C's got to go first because it must be equal to A. B was next, and B is opposite the blue. Opposite the blue in the other triangle is also B, so B goes second. Opposite the red in the triangle on the left is the D. Opposite the red on the right would be D. So the triangle congruency would be triangle ABD congruent to triangle CBD. A being equal to C, B being equal to B, and D being equal to D. Sometimes they're a little twisted, so we got to really take a look at what's opposite what. And for some students, this takes a little bit of getting used to. What is angle A opposite? Well, angle A is opposite the side with one mark. Let's look at this. Side BC, the angle opposite that is A. So A is opposite the side with one mark. The side with one mark is here. Opposite that is E, so this A must be equal to this E, so E goes first. Okay? B was next. B is opposite the side with two marks. So we come over here and find the side with two marks. The angle opposite it is D, so B must be equal to D, so D goes in the middle. And C is the only thing left, but we could follow that same scenario. This side's got three marks. Opposite it is C. We find the side with three marks. Opposite it is C. So C is equal to C, and we know they're vertical. So being vertical, they were going to be equal anyway. So if all three sides of one triangle equal all three sides of another, then the triangles are congruent by side, side, side. But we have to name the congruency in the proper order. And so we have to be thoughtful of this is opposite that. This is opposite that. Okay? We've got to be able to identify angles opposite certain sides and sides opposite certain angles. Okay? Now, postulate 6.2 is side, angle, side. Now, it actually says this formal definition: if two sides and an included angle of one triangle equal two sides and an included angle of another. Two sides and the included angle of one triangle equal two sides and an included angle. Now, I tell people to read this as side, very next angle, very next side. And that may seem a little bit weird, but you're going to see what I'm talking about in a minute. Side, very next angle, very next side. That doesn't mean that we ignore that more formal definition, two sides and an included angle, because that formal definition is important in courses to come and theorems and rules to come. So you really need to understand two sides and an included angle, but you can think of it as side, very next angle, very next side, and we'll talk about both of those things. So let's just kind of focus on that. Two sides. We got this side equal this side equal that side, and so we have two sides of one triangle equal two sides of another. Two sides and what? The included angle. The angle that is included between those two equal sides. You see that? Now, you remember when we talked about opening up that compass? And if you open that compass up a little bit bigger, then you're going to get a bigger angle with a bigger side. Well, if you open your compass up exactly the same, you're going to get an equal angle and an equal side, and you're going to have congruent triangles, you see. That's kind of the thought as we connect it to that little piece of thinking. And so we have two angles in the included side of one triangle equal two angles in the included side of another. But we can see it like this also. We've got a side, the very next angle that follows that side, and the very next side that follows that angle. Side, very next angle, very next side. Which helps some of my students actually see it. We got this side, the angle that follows that side, and the side that follows that angle. Angle, side, side, very next angle, very next side. But this concept of two sides in the included angle is very important terminology. So let's understand both of them as we do this. Now, looking at the congruency, A was opposite the side that was 4. It would correspond to the side opposite the 4, which is D, so D would go first. B was opposite the side that was 3. It's going to correspond to the side the angle opposite the 3, which is F. And the C is 60 degrees, so it's equal to the angle that's 60 degrees, which was E. We already knew those angles were equal, see? And so we very specifically and orderly named the congruency, okay? When we look at this next triangle, we have that side BA is equal to side BC. That was given by the 1 mark, 1 mark. BD of the triangle on the left is equal to itself BD of the triangle on the right by reflexive property. It's equal to itself. The angle included between them of this triangle is equal to the angle included here. So we have two sides and the included angle of one triangle equal two sides and the included angle of another. So we can say that they are congruent by side angle side. Angle A was opposite the red side, so it goes with C because it's opposite the red side. B is opposite that. It's equal to the B that's opposite that, but that was the marked angle anyway, so the B is equal to the B because they were marked equal. D is opposite the blue side here. It's opposite the blue side there, so D is equal to D because they're opposite matching sides. Okay? When we look at the next example, we've got a side of this one, 4, is equal to a side of this one, 4. Another side of this one, 6, is equal to another side of this one, 6. So we have two sides of one triangle equal two sides of another. The angle included here on the top one is equal to the angle included on the bottom one because vertical angles are equal. So we got reflexive property going on. Vertical angles are equal going on. So we do have two sides and an included angle of one triangle equal two sides and an included angle of the other. So we can say that the triangles are congruent by side angle side. Now the A is opposite the red. The D is opposite the red. And so A goes to D. The B was opposite the blue. E is opposite the blue, so B goes with E. And the C's were equal because they were vertical, so we properly named the congruency. So two ways so far to prove that two triangles are congruent. If all of the sides of one are equal to all of the sides of the other, we say they're congruent by side, side, side. The second way is if two sides and an included angle of one triangle are equal to two sides and an included angle of the other, then we can say that they are congruent by side, angle, side. The third way we're going to take a look at proving that two triangles are congruent is by angle, side, angle. Now, angle, side, angle says if two angles and an included side of one triangle is equal to two angles and an included side of another, if two angles and an included side of one is equal to two angles and an included side of another, then we can say that they are congruent by angle, side, angle. We can read this as angle, very next side, very next angle. That seems to help some of my students identify it. Although don't forget that the terminology of two angles and an included side becomes important down the road. Okay? So, examples, we have this angle 50 is equal to this angle 50. This angle 60 is equal to this angle 60. The side included between those two angles is equal to side included between those two angles. And so they are congruent by angle, side, angle. Now, angle A was 50, and angle D is 50, so A and D go in the same spot. Angle B is opposite the red side. Angle E is opposite the red side, and so B goes to E. Angle C was 60. Angle F is 60, and so angle C goes with angle F. Again, we must name corresponding parts in order. Sometimes when we have equal angles, that's pretty easy. If we have sides, we have to look opposite equal sides to find corresponding angles. Okay? Now we're giving you less information as we progress here because we have things like vertical angles are equal and things like reflexive property that we're having to use as we solve these. So let's see what all we've got going here. On this one, we have an angle of one triangle is equal to an angle of another. There's an angle equal angle. These right angles, that's another angle equal angle. So we have two angles of one triangle equal two angles of another. BD is equal to itself BD by reflexive property. So what we have is two angles in an included side of one triangle equal two angles of an included side of the other. So we can say that those triangles are congruent by angle, side, angle. You might notice we have an arc. There's an angle. We have the green side, that's the very next side, and we have the 90 degrees. So here we see, as we look at what's marked there, we have an angle marked, we have the very next side marked, and we have the very next angle marked. So we have an angle marked, we have the very next side marked, and we have the very next angle marked. So we're seeing angle, side, angle in the picture, you see. Now, when you name the congruency, again, you must name corresponding parts in order. The A was first, and the A was opposite that green side. And over here, opposite that green side is C, so the A must be equal to C. The angle B's both had one arc, so that told us that angle B was equal to angle B. And the D's both had a 90, so it tells me D's equal to D. Any questions on that? Those are congruent by angle, side, angle. Well, when we look at the next picture, we have that angle A is equal to angle D, so there's an angle. We have that side AC is 3 and side CD is 3, so we have a side. So we've got an angle and a side. But what else do we have? Well, we've got a couple of things. We've actually got that vertical angles are equal. And if we put in our vertical angles, then what we see, if I just show you the bottom, we've got that and a blue arc and a green arc. Should put 2 arc. And so that's an angle. The very next side, the very next angle, and that's happening with both, so they're congruent by angle, side, angle. We want to name the congruency. Angle A had an arc, and angle D had an arc, and so that told us that A was equal to D, so we put D first. B is opposite the side that was 3, the red side, so it's going to go with the side opposite the 3 over here, E. And then in the middle of all of that, we had C, and we know that the two C angles were equal because they were vertical angles. Vertical angles are equal. So 3 ways to prove that two triangles are congruent: side, 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 angle, side, angle, side, angle. And so let's take a look at the daily work for Unit 6.2. Name 2 congruent triangles and tell how they are congruent. Well, the possibilities are side, 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 angle, side, and angle, side, angle. That's all that we've learned up to this point. So, have this side is 5. This side is 5. There's one pair of equal sides. This side is 6. This side is 6. There's a second pair of equal sides. This side is 7. This side is 7. There's a third pair of equal sides. All 3 sides of one are equal to all 3 sides of another, so we can say that they're congruent by side, side, side. But we want to name the congruency. In the first triangle, A was first. A is opposite what we marked in green, the 7. So opposite what we marked in green, the 7, here is X. So if A is first, X is first, you can see that these triangles all spun around and twisted up. So we're untangling them by looking opposite equal sides to find equal angles. Angle B is opposite the 5, which was marked in red, and opposite that is side B. See? Is side B, you notice? So opposite the red, or the side that was 5 here, is R, and so B must correspond to R. B was in the middle, so R goes in the middle. C, the last one, was opposite the blue. So we would look opposite the blue or just pick the only thing left, which is P, so C goes to P. So they are congruent by side, 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 and we looked opposite equal sides to find equal angles, and we named those corresponding angles equal. Now, here's what this is doing down here. It says name 3 additional equalities that follow from the fact that you figured out they were congruent. We just proved that these were congruent by side, side, side. If we know they're congruent by side, 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 then since we now know they're congruent, we now can say the angles are equal, right? So now we can say, following from number 1, that's this. Now that we know they're congruent for number 5, we now can say that angle A, green, is equal to angle X, green. Angle B, red, is equal to angle R, red. And angle C, blue, is equal to angle P, blue. We're proving they're congruent by 3 things. In congruency, there's 6 equal things. So you're going to look at what 3 things we didn't use to prove they were congruent by. And then we could then say, well, they're congruent because, or those other things are equal because they're congruent. And we could use the reason corresponding parts of congruent triangles are equal. See? All right? All right. We'll let you do number 2 there on your own. Number 3, we have one side of this triangle is equal to a side of this one. We have a second pair of equal sides. We know that vertical angles are equal all the time. So we have 2 sides at an included angle of one triangle equal 2 sides at an included angle of another. So we can say that those triangles are congruent by side, angle, side. Angle A was opposite the blue, so we look opposite the blue, which is Z, so angle A is equal to angle Z. Opposite the red, angle B is opposite the red, angle Q is opposite the red, so B goes to Q. The C's were equal because they're vertical, and so we named the congruent C. Now, what did we use to prove they were congruent? See what's marked, including our vertical angles now? We proved they were congruent with 2 angles and a side. That means this other pair of sides that we didn't know were the same, we now can say they're the same. Now, those don't look the same, but we're making that assumption. Sometimes your eyes can confuse you too when you look at things. They may really be exact and it will be deceiving to your eyes. You can actually measure and find out. But anyway, that third side we can say is equal, but look at how we have to name it. AB. AB has to go with Z first Q. So following from number 3, we can now say that AB is equal to ZQ. And then we could say that this angle A is equal to this angle Z, A first, Z first, C. Angle A is equal to angle Z. We now could conclude that angle B is equal to angle Q, angle B is equal to angle Q. So we prove they're congruent using three equalities. Knowing they're congruent, then we could say that the other three sets of things are equal. And we could justify that with the reason corresponding parts of congruent triangles are equal, which we'll talk about later again. And we'll let you handle number 4. Number 4 does have parallel lines, and so when you see parallel lines, you're looking for alternate interior angles are equal, that make a Z. Corresponding angles are equal, that make an F. Same side interior angles are supplementary, but that doesn't help you because we need equal stuff to prove congruency, right? So you need to be looking for either alternate interior angles or corresponding angles, given that those two lines are parallel. Any questions so far? Okay. We're going to supply the reasons for the given proof. Okay, number 9, supply the reasons for the given proof. So we're going to get you started again, and I'm going to leave you with a little bit more of this. We're going to take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the notes section. What we marked is exactly what it gave us, so we put given. We're going to read the next given statement. It says ray BC bisects angle ABF. What we get out of an angle bisector is two equal angles. So we mark that they're equal. Ray BC bisects angle ABF. Therefore, angle ABC is equal to angle FBC. Reason, definition of an angle bisector. And what we see as we have our mind on congruency is a side and an angle and a side and an angle. And you can go from there, okay? So then you would give reasons as we said before. Look first in the given, second at the diagram. When you look at the diagram, then you would know to look in the note section. And then third, you would look at the statements above, okay? The next proof is an on your own proof. Let's go ahead and do that proof together. I'm going to white out the bottom. When we do a proof, we write the given proof, put the statements on the left, reasons on the right, draw the diagram. We take what we're given, we mark it in the diagram, we write statements and reasons derived from the markings in the notes section. You're going to think about all the ways to prove the proof part. You're going to use the given and the diagram to eliminate as many ways as possible and come up with the ways to prove it. Once you come up with the way you're going to prove it, you're going to make all your statements and reasons say what that method of proving it says. Once you've done that, you will check your statements and reasons from the bottom up to make sure that your proof is in the right order and that you need everything that you've put in your notes section, and then you will transfer it from your notes section into the proof itself. So we've already got it all set up, given proof statements on the left, reasons on the right, and the diagram. So now we're going to take what we're given, DAE is equal to DEA. Angle DAE I missed. 1 second. So angle DAE is equal to angle DEA. So we're going to write that in our notes section because that's what we marked. Angle DAE is equal to angle DEA given. We take the next given statement. It says BD is perpendicular to AC. So we say the definition. Perpendicular lines form equal, adjacent, 90-degree angles. BD is perpendicular to AC. So these angles are equal, adjacent, and 90. Now, I can say that angle ADB, the green one on the left, is equal to angle EDC, the green one on the right. By definition of perpendicular, perpendicular lines form equal, adjacent, 90-degree angles. Now, I know that if I'm going to be able to say definition of, I need the word and what I get out of it. So I'm going to go ahead and put the word in there. BD is perpendicular to AC, reason given. It then says BD is equal to CD. BD, that's the whole thing from here to here. I'll put one mark in it, is equal to CD. Excuse me, that's from here to here. I'll put one mark in it. BD equals CD, reason given. Now, we want to try to prove that those are congruent. And the only way that we can do that, you see, is by side, 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 side angle, side, or angle, side, angle. So here's what we've done so far. We wrote the given proof, put the statements on the left, reasons on the right, drew the diagram. We took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the note section. Now we're going to look at what we're trying to prove. We're going to make that proof statement the last statement in our proof. We're going to try to make that proof statement the last statement in our proof. We need a reason for that. So our job is to find a reason that we can reach the conclusion we're trying to reach, that triangle ABD is congruent to triangle ECD. So we're going to think of every way that you can prove what we're trying to prove, and that is that two triangles are congruent, and the only choices we know so far are side, 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 angle, side, and angle, side, angle. So we need to think about what we're given so far and what else we need and what else we could conclude. So if we look at what we're given so far, and we look in the picture at what we're trying to prove, then what we're trying to do is prove, and I think I'll just maybe color code this. This may be the easiest way to go here. We're trying to prove that this triangle BDA is congruent to this triangle over here, which is triangle ECD. Now, what we've got as far as one triangle and the other triangle is we've got the little green angles. So we've got an angle and an angle, and we've got the blue sides, and so we have a side here and a side here. And so all we have as far as the two triangles is a side and an angle. We don't actually have, see those little red angles? Those are not in one triangle and one in the other. So that really does, as far as a side angle side or a side side side. But we do know that we're given a side and an angle, so we're pretty well going to trash side 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 and say, well, it's down to one of these, side angle side or angle side angle. Now, here's the thing, and we'll try to color code this. I may even try to get a crazy marker on this one. If I'm going to prove that they are congruent by side angle side, let's just say, then what I have is I have a side and an angle, and I would need the very next side, which is that. And so here I have a side and an angle, and I would need the very next side, which is that. And so we say, well, if I'm going to prove it by side angle side, I need to know that that side of the pink triangle is equal to that side of the blue triangle. And we think, well, is there anything else we can see that would allow us to prove that? And you might could visualize this little green triangle right here, you see. And we want to know if those two sides of that little green triangle are equal. And we had marked in that little green triangle that this angle was equal to that one. That's this statement right here. Now, we know from our isosceles triangle stuff that if two angles of a triangle are equal, then the sides opposite those equal angles are equal. That's enough information to get that third side we needed. Side angle, side, side angle, side. So we can conclude, we want to try to prove these are congruent then by side angle side. And we know to do that, we needed to say that that third pair of corresponding sides were equal. In other words, the bottom of the pink triangle AD is equal to the bottom of the blue triangle ED. But we need a reason for that. And the reason was sides opposite equal angles are equal. Sides opposite equal angles. And I just put the letter R equal, and it stopped me at the end of the board. Sides opposite equal angles are equal. Well, it looks like we kind of got done there, doesn't it? All of a sudden, I wanted to prove it by side angle side, and to do that, I needed to know that that third set of sides were equal, and I could say that because I knew that those two red angles were equal, and so side opposite equal angles were equal, and all of a sudden, there's no blanks to fill in. So we think, well, maybe we're done. Well, to see if you're done, you're going to check the reasons from the bottom up, and I'm gonna use a highlighter here to do that, so maybe it will be a little bit easier to keep up with. I'm just going to use yellow. I think that will jump out at us here. So we're going to say, okay, if I'm going to prove that they're congruent by side angle side, prove that they're congruent by side angle side, then I need a side equal side, an angle equal angle, and a side equal side. I need those three statements to say side angle side, but I would prefer that my angle be in the middle so I actually see side angle side. So I'm going to scoot that angle down in there. Okay? So I know I'm going to do that. I'm going to change the order. I'm going to put this in the middle. So it says side angle side. It looks prettier that way. So I'll go to the next given reason, a statement. So this statement and reason is justified. Okay, that's good. So I'm going to go to the next needed statement, which is this, and then the reason is sides opposite equal angles are equal. Before I can say sides opposite equal angles are equal, I need to know that the angles are equal, and those angles were equal given, and so I needed this statement to make this reason, and that reason's justified, so it's good, that statement and reason. The next needed statement, so that's justified. The next needed statement was BD equals CD. That was, the next needed statement was that the angles were equal. And I say they're equal by definition of perpendicular. To say definition of, you need the word and what you get out of it. Here's the what you get out of it. There's the word, so that's justified. The next needed statement was the other side, and that was given. All of a sudden, we see that every statement and reason was justified. To make this statement, also needed to know that they were perpendicular, which was given, and that was given. And all of a sudden, we got everything we need. So we said we just want to slip this one in here. This will be statement 1, reason 1, statement 2, reason 2, statement 3, reason 3. We're moving the angle down here to the middle. Statement 4, reason 4. Statement 5, reason 5. Statement 6, reason 6. We proved that they were congruent by side angle side. Any questions on that? Okay. And we're going to let you do the last proof all by yourself, but you know that in the odd answer solutions, there's a pretty good hint, since the whole thing's worked out. Anyway, try to do it on your own. Don't just go back here and copy it because you're not going to learn anything that way. So take the time, try to do the proof. You get stuck, go back here and try to work it out. Okay, we want to expose you to some more word problems, so we're going to go ahead and get you started on this word problem. We may let you finish on your own. It says Billa had 6 more than twice as many A's as Sally. Now, back on page 40 in the Algebra 1 textbook, we would have called this a comparison between two characters. The characters would be Billa and Sally. And so we would put this on a word sentence line. And what would go on the word sentence line would be the characters, the verb because it means equal, and anything that means add, subtract, multiply, or divide. And so we would put Billa B had 6 more than twice Sally. We would change that to a mathematical equation. Subject, verb, subject equal. 6 more than means I'm gaining. What I'm gaining, the 6 goes after the plus. 6 more than what? Twice S. And I'm going to make that a lowercase s so it will look like a 5. If Sally had 4, then how many did Billa have? So Billa had 2 times Sally, which was 4 plus 6. Now we're to the order of operations, and you can solve. Any questions on that? Okay. And that's the daily work for 6-2.